Hi kids, let's have a look at this upper and lower bound question. First of all, let's read the question. It says n is equal to the square root of r over s. R is equal to 3.74, correct to 2 decimal places. S is equal to 8.123, correct to 3 decimal places. By considering bounds, work out the value of n to a suitable degree of accuracy, and then give a reason for your answer. This is a 5-mark question. Oops. So, as I was saying, 5 marks. And I'm going to talk you through the question and through how you can get the marks for it. So, let's make a start. It says by considering bounds, so that means we have to work out the upper and lower bounds for both our numbers. So, let's make a start with r. R is equal to 3.74, correct to 2 decimal places. So these 2 decimal places refers to the place value of the second decimal place. The second decimal place's value is 100th. So 100th. Okay, so that's going to be equal to 0.01. So that's my second decimal place, is 100th. After you work out what the place value of whatever degree of accuracy the question wants from you, have to divide that by 2. I suggest you always do that in your calculator. So in my calculator I'm typing 0.01 divided by 2, and it gives me 5 times 10 to the power of minus 3, so it's annoyingly in standard form, but I can recap standard form as well quickly. So because of the negative power, I know my decimal point is going to go left. It's going to go 3 spaces left because the power is minus 3. So it starts from the end of the number and goes 1, 2, 3. Ends up somewhere here. So every empty space I fill up with zeros. So that means the number I've got is 0.005. Once you got this value, to work out the lower bound, you take your number and you add whatever value you take away, because we're doing lower bound first. So we're doing our number, which is r 3.74, take away, because it's a lower bound, whatever you just worked out. In my case is 0.005. So again, I'm doing this in my calculator. It's not worth it losing marks just because I'm thinking I can do this in my head. So the lower bound for r is 3.735. Okay, and if we want to work out the upper bound, same, we start with our value that we're given, but we add instead of taking away. Okay, I'm going to plus 0.005. Again in my calculator. So it gave me 3.745. Okay, so these are the upper and lower bounds for r. Let's do the same thing to s. This one is correct to 3 decimal places. So for s, the third decimal place is a thousandth. So I'm not looking at the numerical value, I'm not looking at the 3, I'm just looking at the place value of the number. So third decimal place is always going to be a thousandth. So 0.001. Again, I divide that by 2. So 0.01 divided by 2. Again, super unhelpfully in standard form. So 5 times 10 to the power of minus 4. I'm going to write down my 5. And then I need to move the decimal point 4 spaces left. So I start here and I go 1, 2, 3, 4. Decimal point ends up there. All the empty spaces get filled with zeros. So that means, let's see if this will work. Okay, so that means, as I was saying, that my decimal point is going to be there. So 0.0005. Again, to work out the lower bound, I take my number, so my value for S, which I'm given 8.123, and I take away my value, so 0.12305. Type that in your calculator, so 8.123 minus 0.12305, and predictably I get 8.1225 for the upper bound. Again, I take my value for S, 8.123, and I add 1, 2, 3 zeros, 4, 5, 5. Do this in your calculator, and I get 8.1235. Okay, so believe it or not, all this work we've done so far is just worth 1 mark. The next mark we're going to get is using any of these bounds that we worked out in any random way. But I want to progress with a question, on the right track. So that's why I'm going to stop and I'm going to have a think of what the question is asking me, what I have to do. So considering bounds, work out the value of n to a suitable degree of accuracy. What this is asking you to do is it's asking you to figure out what value, to what number do both the upper bound and the lower bound of the number round to. So what's the finest rounding that you could do for this value? So we have to work out the upper and lower bound for n now. So to work out the lower bound for n, what you're looking for is a combination of upper and lower bounds that is going to give you the smallest possible value for n. So I need to have a think about this one. So to get the smallest possible number when I'm dividing, that means my numerator has to be the smallest number I could get. So I'm going to go for the lower bound for the numerator. And my denominator has to be the biggest possible number I could get. Because the smaller the number you're dividing, and the bigger the number you're dividing by, the smaller your answer is going to be. So I'm going to choose the upper bound. So the lower bound for R and the upper bound for S. And let's do this calculation. So I have to square root my R. Let's not forget that. So I have to square root the lower bound of R. I've got 3.735 over the upper bound of S, 8.1235. Type that in my calculator. Okay, fraction button, so I'm doing square root button, 3.735 divided by 8.1235, and the answer I get for the lower bound of n is 0.237904.205. I'm being a bit extra writing all this down. I wouldn't say really necessary, but I just want to make sure that my rounding is correct for the final answer. Okay, so let's have a look at our upper bound now. So to work out the upper bound of the number, again for n, you have to sit and think about it, so don't just jump in, I would say. So I'm looking for the biggest possible number I could get when I'm dividing. So the bigger the number I'm dividing and the smaller the number I'm dividing by is going to get me the biggest possible answer I could get. So that's the reason why for the upper bound of n, I'm going to use the upper bound of r over the lower bound of s. And again, let me write this down. So I'm doing upper bound, which is 3.745 over this one, the lower bound of s, which is 8.1225. So if I type that in my calculator, again, don't forget to square root 745, 8.1225, and the answer I'm getting for this one is 0.238 2518, so on and so forth. Okay, so let me tell you a bit about marks. At this point, we've got another 3 extra marks. So one of the marks is for using any bounds in calculation. So even if I would have done them random and just chosen anything and went with that, I would have still got that mark. The second one is for using the bounds correctly. So for using the lower bound over the upper bound for lower bound, and using the upper bound over the lower bound for the upper bound of n. So using them correctly gets me that second mark that I'm telling you about, the third mark overall. The fourth mark I get for getting these answers, so the lower bound and the upper bound for n. So that's the accuracy mark, which if you don't get them right, you don't get the mark. All the ones before were methods, so method marks. Right, so this is a 5-mark question, so what I have to do now is I want to justify my answer, because it says give a reason for your answer. So we're going to say that the answer is okay, and now we have to make a decision. So what you want to work out is what's the highest degree of accuracy you can round both numbers so they both have the same value. So for example, if I round both numbers to 1 decimal place, I'm going to get 0.2 for both, which is cool. But let me see if I can round them to 2 decimal places and still get the same answer. So if I round them both to 2 decimal places, I'm going to get 0.24. Okay, so it's still the same. I can carry on and check, can I make it even finer? Can I give it a even better degree of accuracy? If I round them to 3 decimal places now, that's the third decimal place, that's going to round to 0.238, and I'm going to do the same for this one, and again the answer is 0.238. So they're both still the same. Now if you carry on and you try to round them to 4 decimal places, you're going to notice that it's going to be something completely different, so they stop being the same. That's why the final answer is 0.238, because both numbers round to this value. Okay, and that's it. So if it says give a reason for your answer, just make sure you say something, anything worded. Okay, obviously reflecting your answer. Alright, hope you enjoy this one and looking forward to see you for the next one. Bye!